Okay, in this video, we're going to solve a non-homogeneous differential equation using the Laplace transform. So here we have y double prime plus 3y prime plus 2y equals e to the t. Instead of being a 0 on the right side, we have some other function. And we have two initial values, y of 0 equals 1, y prime of 0 equals -6. So I'm going to take the Laplace transform of both sides, and we'll split it up into separate Laplace transforms. We're going to factor out the constants. And we have to take the Laplace transform of the other side as well. And I'm going to use my two formulas for taking the Laplace transform of a derivative. So for the second derivative, it's going to be s squared Laplace transform of y minus s y of 0 minus y prime of 0. And then I've got 3 times the Laplace transform of y prime. That's going to be s Laplace transform of y minus y of 0 plus 2 Laplace transform of y equals the Laplace transform of e to the t. All right, so now I'm going to take care of my initial values. So anywhere I see a y of 0, I'm going to replace that with 1. Anywhere I see a y prime of 0, I'm going to replace that with -6. So now I'm just going to simplify. I have s squared Laplace transform of y minus s plus 6 plus 3s Laplace transform of y minus 3 plus 2 Laplace transform of y equals, and we can take the Laplace transform of e to the t. We're using this formula. So it's going to be 1 over s minus 1. So let's group the things that have Laplace transform of y together and factor out that Laplace transform of y. So that leaves me with s squared plus 3s plus 2, right? That's from these three terms. And then whatever's left, I just need to move it to the right side. So I already have a 1 over s minus 1. So now I need to add s to both sides. And let's see, 6 minus 3, that's 3. So I need to subtract 3 from both sides. Now I solve for the Laplace transform of y by dividing by this s squared plus 3s plus 2. You have to distribute division just like you distribute multiplication. Whoops. Got carried away there. All right, so how about we combine these into one big fraction? That way we only have to do partial fractions one time. So I need a common denominator. So I need to add a s minus 1 into this denominator. That means I've got to add a s minus 1 in the numerator. Right, so now if I add these together, get s minus 3, s minus 1, plus 1. I need to simplify the numerator here. So I get s squared minus 4s plus 4. That actually factors into what, s minus 2 squared. I don't think that helps us any. But now all I need to do is partial fractions. I'm going to say this is a over s plus 2 plus b over s plus 1 plus c over s minus 1. So now if I multiply both sides by this denominator, I just have s squared minus 4s plus 4 on the left. When I multiply by the first term, the s plus 2's are going to cancel, so I'll have a times s plus 1, s minus 1. When I multiply times the second term, the s plus 1's will cancel, and I'll have b times s plus 2, s minus 1. And then times the last term, the s minus 1's will cancel, and I'll be left with c times s plus 2, s plus 1. Okay, so now, we could plug in some test values for s. Some people do that. I'm just going to set up a system. Let's multiply all this out, simplify it. So I'm just going to multiply this. We get a times s squared minus 1, right? So sum and difference. Then b times, let's see, s squared minus s plus 2s minus 2. And then c times s squared plus s plus 2s plus 2. I'll just simplify this a little bit. Adding the like terms together. All right, so let's compare our coefficients. So all the coefficients of s squared, they have to add up to be 1, right, in front of this s squared. So what do I got? I've got a plus b plus c, that's got to equal to 1, right? If I multiply this a, b, and c inside these parentheses, right? And then what about the s terms? I don't have an s term here, but if I add the coefficients of the s terms, that's got to equal -4. So I've got b plus 3c has to equal -4. And now the constant terms, these have to be equal to 4. So I've got -a minus 2b plus 2c equals 4. So I have a system of 3 equations with 3 variables. I think it makes sense here to use a matrix, right? So use your linear algebra knowledge. So coefficient matrix, augmented, just need to row reduce this. Now I like to use a program called Desmos. So let me show you that. So desmos.com, and they have a matrix calculator. So I can put this matrix in, row reduce it using RREF. And here you can see that it's giving me decimals. You can switch those to fractions. And there you go. There's our solution for A, B, and C. So I'm just going to write these down. I hope you remember this from linear algebra. You could solve it without linear algebra, but matrices are our friends, right? Going to make things easier. So this tells me A, this tells me B, and this tells me C. So I get that the Laplace transform of y is equal to A over, what was it, s plus 2 plus B. I need to go ahead and put B in. B is negative 9/2 over s plus 1. And C is 1/6. That's going to be over s minus 1. So now we just need to do the inverse Laplace transform of both sides. And let's go ahead and pull out these constants. And then we just use our Laplace transform table to do all these inverse Laplace transforms. So we're just going to end up with exponential functions, right? So it's going to be 16/3 e to the negative 2t minus 9/2 e to the negative t plus 1/6 e to the t, right? And this is like your, this is your complementary solution, if you remember doing that. And this is your particular solution, right? We used to use, or we could have used undetermined coefficients to figure that one out, right? So Laplace transforms gives you a way to do these. Now, of course, you have to have the right initial values to do this, but this is very similar to just doing it as a homogeneous equation. So hope this helps.